Hello everyone, I'll be explaining how different data structures offer unique capabilities for storing and manipulating data. Let's explore the three fundamental structures: arrays, array lists, and linked lists. An array in Java has a fixed size collection of elements of the same type. It provides a way to store and access a sequential collection of elements. Moving on to array list, which is a array that can dynamically resize itself as elements are added or removed, and it provides a resizable array implementation of list interface. On the other hand, linked list in Java is a double-linked list implementation of the list interface. Each element of the linked list is a separate object containing a reference to the previous or next element. So here's the first example for array list. So basically here we can change the value at the index 2. We can see that there is an iteration from 10 to 40, but we are modifying an element at the index 2. And when you run this example, we can see it's changed here. And the following, so what does this example tell us? Arrays allow direct access to elements using index-based retrieval and modification. However, their size is fixed upon creation, limiting flexibility. So let's move on to array list example. Here we, using the add method, we add 1 through 40 integers effortlessly into the array list, and we can here, by using the get method with index 1, we retrieve the second element 20 from the array list. This illustrates the ability to access specific elements by their index. And here, using the contains method, we check whether the value 30 exists in the array list. Since it is true, it will return true. And here we use the remove method to remove the value 20 from the array list. And here we use the size method to help us determine the size of the array list, which currently stands at 3 elements. And we also check if the array is empty with the isEmpty method, and we also can clear the array list using the clear method. So let's run this example and see how it runs. Okay, so we can see it worked pretty well. So what does this example tell us? It showcases the versatility of array lists by adding, accessing, modifying, and clearing elements. Moving on to linked lists. For this example, I wanted to make a basic playlist, a way to add or add in the beginning of the add songs in the beginning of the playlist and add song at the end of the playlist, as well as remove song from the first remove the first song or the last song. So we can see here the methods used are add first, add last, and remove first and remove last. So it basically adds and removes songs from the end and the beginning. So let's run this example, and we can just see initial playlist, and then it adds song at the beginning, and then it adds song at the beginning and the end, and then it removes song from the first, and then it removes the song from the last, and then at the end it's just the initial playlist itself. So now let's Now let's talk about stacks and queues. So this is my first example for stacks. It's a simple example about stacking books and how when you're moving books, you take the last one first. So if you're stacking the books, book 1, book 2, book 3, so when you're retrieving it, like when you're removing, you're obviously going to remove the last book. Yeah, so here you're using the push method for stacking them and the pop method for removing it. When you run this, it says removing book 3, book 2, book 1. So now we're moving on to queue example. So it's a very basic example how people in a queue, and obviously when you're serving people in the queue, the first one gets served first. So yeah, you use the you use add method to add people in the queue, and then use the remove method to remove people. Yeah, so when you run this, you get person 1 served first, and then person 2, person 3. Okay, so lastly, I want to talk about hashtables. So in this example, I basically wanted to add a key integer associated with each student. So when you retrieve a key integer, the student's name also will appear. And obviously, if there is no key, then it would just say not found, student ID not found. Let's run this example and let's see how it works. So retrieving information for student ID 102, as mentioned here, and the name is Dante from the list. So what is hashable and how it works? The hashable here for this example, it efficiently associates key with values, allowing quick access to information based on specific keys. Conversely, an array offers direct access to an element by an index, but it does not inherently provide a key value association. So that's what hashable is basically used for. Thank you.